In this video, we'll take a look at the vertical line test and do some examples applying it. So the vertical line test is used to determine if a graph represents a function. So if any vertical line passes through a graph more than once, then the graph does not represent a function. If no vertical line passes through the graph more than once, then the graph does represent a function. So the whole idea here, I'm just going to make a little makeshift graph here. If you've got a value of x, and you've got two different points that are on the same vertical line, okay? If I draw a little vertical line, I'll dash it through there. That vertical line crosses that graph in two places, right? At these two values. So what is that telling us? It's saying that for a given value of x, we've got two different possible y values, right? And we know from the definition of a function that that can't be, right? So the vertical line test is a good way to visually see whether the graph is a function very quickly, because what it's doing is it's testing a value of x and determining whether or not it corresponds to two different y values. Okay, so let's do some examples. So which of the following are graphs of functions? In either case, state the domain and range of the relation. Okay, so by the way, all of these are relations whether or not they're functions or not, so we can still state their domain and range. Okay, so for part A, this first function, boy, I'm looking at this graph, I've got problems, right? So if we've got here just at x equal 2, I've got three different places where a vertical line crosses the graph, and there's obviously many vertical lines that we could draw where this would cross in more than one place. So is it a function? No, because it fails the vertical line test. There are multiple values of y for a given value of x. And what's the domain of it? Well, because the arrows are extending in the negative and positive direction horizontally there, I'm going to say all real numbers. And what's the range? All real numbers as well, right, with those arrows. So in this next example, it looks like any vertical line we draw here on this graph, it's going to cross just one time, right? So for each value of x, there is only one value of y. So we would say, yes, it's a function. And again, the domain here, negative infinity to infinity, right? Because there are those arrows will just continue to go up and up and up and up, and all of the x values will be accounted for. Same with the y, right? We're extending in the positive and negative direction there. Okay, this last example is a function. It's a circle. So if you can draw any vertical line that crosses that graph twice, it's not the graph of a function, right? Because we've got a value of x that corresponds to two different values of y. So we would say nope. Fails the vertical line test. But the x values extend from what? Looks like -3 to 3. And same for the y, right? It's a circle centered at the origin with a radius of 3. Okay, so hopefully you got the idea. The vertical line test, if you can draw any vertical line on the function and it crosses in more than one place, then it's not the graph of a function.